Hypothesis testing for means, our tutorial. In the lecture today, you saw Jeff extend the idea of hypothesis testing and apply it to the mean or average value of a measured quantitative variable. Let's see how we can use R to test a hypothesis about a population mean mu. We'll begin with Jeff's example of the plastic surgery patients and their perceived age change. We'll read in the data and set change equal to the first column V1 in the dataset. To calculate the test statistic using R, we will need the mean age change, x bar, the variance, s squared, and the sample size, n. We will enter our calculated statistics into the formula. We have x bar minus the null hypothesized mean, 0, divided by the square root of s squared over n, and we obtain a test statistic of 18.86. Now the p-value is the probability above 18.86 from the t-distribution with n-1 degrees of freedom. We can use the pt command, inputting our test statistic value t, the degrees of freedom n-1, and since we would like the probability above the test statistic, we will specify lower.tail equals to false. We can see that with such a small p-value, we can reject a null hypothesis. We have very strong evidence to suggest that on average, people looked younger after the plastic surgery. For an example on a two-sided test, let's look at the body temperature dataset, and again, the first column is the one we will refer to as temp. R has a built-in function t.test for conducting hypothesis tests for a mean. We will use it on our variable temp, specifying also the null hypothesized mean of 37, and that the alternative hypothesis should be two-sided. In other words, we are testing whether the true mean temperature differs from 37 degrees. We see in the output our test statistic of negative 5.455, our degrees of freedom 129, and the p-value. Since this p-value is very small, we can reject the null hypothesis and conclude the alternative, that the true mean temperature is not equal to 37 degrees. As part of the output, we also obtain a 95% confidence interval and the sample estimate of the mean, or x bar. If you wish to change the confidence level for the interval, you could do so with the optional argument conf.level in the t.test command.